Hello everybody, today we will be going over a trigonometry problem at the IB Math AISL level. So we have the diagram below that shows a quadrilateral ABCD with side lengths AD12, that's this guy here, DC7, this guy here, BC5, this guy here, angle bad, which is this guy here, angle BCD, which is this guy here, see? So all the information that was given to me is already in the diagram, beautiful, there's nothing new I have to do there. Later on, they tell us that a new line is drawn from B to D direct. So that would be something like this, ¿cierto? What does that do? Well, clearly, it makes one triangle here and another one here. See? So now we have two triangles now that I drew that line. For part A, we need to calculate the length of this new line BD. Now, with trigonometry, there's usually more than one way to approach problems, and the way that I suggest is always the same one, ¿cierto? So what I suggest is go for the number one boy, the sine rule. See? The sine rule, as you've seen in my other videos, works in pairs. Take a moment. Do you have the pairs to solve this? Let's remember that the sine rule asks for a distance divided by a sine angle, ¿cierto? Equaling another distance, right? So I'm going to call this distance 2, this one distance 1, angle 1, divided by sine angle 2, ¿cierto? So this is like mega intuitive how the sine rule works, ¿cierto? So you need a distance paired with its angle equaling another distance paired with its angle, ¿cierto? So let's take a moment and see if we have any pairs here. This 7 here, with what angle is it paired? It's paired with that guy there, which I don't have. So that is half a pair, ¿cierto? This guy here goes over there, another half a pair. I don't have that either, ¿cierto? And finally, this angle here goes with that side there, the side we're trying to find, another half a pair, ¿cierto? So again, I'd have a bunch of half pairs. I'd always be having two variables and not one. I would not be able to solve this. I cannot use the sine rule, ¿cierto? If I had one whole pair and one half pair, then I'd be able to find the missing guy, ¿cierto? But in this case, I'm always going to have two missing ones, see? In this case, I have always two half pairs, ¿cierto? And so, well, I can't do it, see? The sine rule, unfortunately, does not work. You want to try to train your eye to see it, so it's always worth to take a second and see, hey, can I use the sine rule or not? ¿Cierto? Now, since I can't use the sine rule, we go down the list of tools. Now we have the cosine rule. ¿Cierto? The cosine rule is always a little more weird, but there's two versions of it, which is really, they're just rewritten. It's basically the same one. I like to use the one on the left. The one on the left looks like this. C squared equals a squared plus b squared minus 2ab times cosine c. See? So notice, what are the special ones here? What do I mean by special ones? If we see here, a and b are both being multiplied, and a and b here are both being added. So I can switch b and a, and the formula works the same, is what I'm trying to say. ¿Cierto? On the other hand, we have c. ¿Cierto? C here is alone, and c here is inside cosine. So it's very important which c you pick in this scenario. Now notice, all of these are little letters, so they are all sides except for this guy here. This guy here is an angle. Aha, something special going on here. So the side that we're trying to find, cierto, this guy in green, we need the other two sides and its corresponding angle. Do I have the other two sides of DB, cierto? So I have the other side here, the other side here. And do I have the angle paired with DB? Why, yes, I do. Of course I do. So that is all the information I need for the cosine rule, so I will go ahead and apply. It looks something like this. dB squared equals, I'm going to call this guy A, see? So, it's going to be 7 squared. I'm going to call this guy B, ¿cierto? Plus 5 squared minus 2 times 7 times 5 times, sorry, I ran out of space, cosine C, cosine 100. All right, that is how you set it up. So dB is the square root of that whole thing. See? Now that whole thing, trust me, I'm going to do my calculator now. So square root of 7 squared plus 5 squared minus 2 times 7 times 5 times cosine 100. Awesome possum, we get 9.281. So dB is going to be 9.81. Sorry, 281. 281.9. See? So part A, dB equals 9.28199. See? Awesome possum. That is for part A. Now for part B, we need to calculate the size of the angle ABD. ¿Cierto? So again, we are dealing with a triangle. We have this side over here, which we said was 9.28, ¿cierto? Roughly. And we need to find the angle ABD. See? So again, process is important. What is the most useful tool? What is your number one? Your number one is the sine rule. So can I apply sine rule here? Sine rule, we had said, was distance 1 divided by sine of angle of that distance, ¿cierto? Equals distance 2 divided by sine angle of that same distance. See? So let's try to see if we can use sine rule here, ¿cierto? This angle is paired with that side, so that is a whole pair, ¿cierto? And this angle that we're trying to find has the half pair this distance. See? So that means I would be plugging in something like this. Boom, boom, boom. I'm only missing one variable. I can use it. See? So if I plug it in, it would look something like this. My distance 1, we're going to call 9.2819 divided by sine 50 equals distance 2, we said was 12, divided by sine of angle ABD. See? All right, awesome. So now I just need to get ABD alone and solve. So I start off by cross multiplying. I have 12 times sine 50 equals 9.2819 times sine angle ABD, ¿cierto? I want to get this guy alone, so I'm going to actually divide by 9.2819 to both sides. That makes me end up with something that looks like this. And now since I still want to get this ABD alone, ¿cierto? My next step is to use sine inverse, see? And so what sine inverse does is that it gets rid of the whole sine part, ¿cierto? I end up with just the angle. However, sine inverse needs to get applied to both sides, so I'm doing sine inverse of this whole thing over here, see? So sine inverse, as I said, gets rid of your sine, which looks like this. Get rid of the sine, but you keep the angle inside, ¿cierto? So whatever this equals will equal my angle ABD. All right? All right. Let's check our calculator, see what it does. So I'm going to do second sine inverse alpha y equals the first one to use my fraction. I think it's just easier to do it this way, but to each their own. 12 on top, sine times sine 50 on top. I go to the bottom, 9 point blah blah blah, ¿cierto? Whoops, that was a mistake. I thought I could plug it in directly. Apparently I cannot, or maybe there's a way, but I don't know. Doesn't matter. Equals 82, ¿cierto? So my angle is going to be 82.0388. See? So that is for part B, angle ABD. All right, so notice, for both part A and part B, I started the same way. I started by looking at my number one. My number one, who was it? The sine rule, see? Sine rule is the easiest one to use. It takes a little bit longer sometimes, but it always works. See, so keep an eye out for sine rule. If sine rule doesn't work, go to your next tool, probably the cosine rule. And if that doesn't work, even though it should, then there has to be something fishy going on. You can probably use SOHCAHTOA, or maybe there's some information of the triangles you haven't filled in yet, like finding a missing angle or stuff like that. But A, process is important. Go sine rule, then go cosine rule, go from there. See? So that is part A, that is part B. Those are my suggestions. I hope it helped, and I'll see you on the next one.